Hi students, so welcome you all again. We shall continue with the previous slide where we have left. So in this session, I am going to continue the previous session with domain, codomain and range. So first let us discuss what was the function again. Once you understand what is the function very carefully or very neatly, then you can go through the further things very easily and you can understand it. So for that reason, I am going to explain you about the function again and then let us move forward. Okay. So here they are discussing about domain, codomain and range. So domain means what, codomain means what and range means what. Let us discuss. Clear? So already we have seen about function. Okay. If I want to say f is a function from a to b. If I want to say f is a function from a to b, I has to satisfy with one particular condition. That is, each and every element of set A, each and every element of set A should relate, each and every element of set A should relate every element of B in unique way, every element of B in unique way. That means first element should have some unique image, second element should have some unique image, third element should have unique image, fourth element should have unique image, and fifth element must also have unique image. See here, 1, 1, 1, 1 and 1. All are having unique images from set A to set B. So therefore, this is called function. Clear? Suppose, see, this is set A, this is set B and this is the relation F. Now, I have some 3 elements. Here also I have some 3 elements. If I have images like this, then this is not unique. Therefore, definitely this is not function. Clear? Next, one more thing. This is set A. This is set B. I have image, unique image, I have unique image, I have unique image, and this is relation F, this is set A, this is set B. Now it is not function. Why? See this. This is not having any image. This is not having any image. That's why the third one is not function. First one is function. Second one is not function. Third one is also not function because of the last element. Here because of the first element. Here it satisfies the definition of function. So that's why it is function. No problem. Clear students? Okay. Now you got an idea of what is function, right? So with this idea of function, now I will take one small example and I will make you to understand what about domain, codomain and range. Already they have taken one of the example here and they have discussed. So I will also take another example. Before taking one new example, let us discuss this. Okay. So here what happens, see students, in set A there is A, B, C, D, 4 elements. In set B there are again 4 elements, 1, 2, 3 and 4. Clear? Here what happens, here what happens, this is unique image, this is unique image, unique image, unique image. Therefore, the given thing is function. The given example is function. No problem. If this particular thing, see here, if this particular thing becomes an a function, if this particular things become an a function, this is called mapping. Please understand it. Before becoming an a function, we call it as arrow diagram. Before becoming an a function, we call it as an arrow diagram. But when it satisfies the condition of a function, if it becomes function, this arrow diagram becomes mapping. The word will change as mapping. Clear? This is the first thing. And the second thing, set A will become domain. Set A will become domain. Set B will become codomain. Set B will become codomain. Clear? So A, B, C, D are the four elements. See here. A, B, C, D. This is set A. It's called domain. Next, P, Q, R, S are present in set B. It is called codomain. It is called codomain. Clear? All the elements P, Q, R, S, four elements are present in codomain. So that's why it is called as codomain. Clear? Next, range. So you have to collect the images. You have to collect the images. For example, here P, Q, R are the three elements which are images of A, B, C, D. P, Q, R are the images of A, B, C, D. That's why this is called range. That's why this is called range. Clear? So first thing, it becomes mapping by satisfying the condition of function. Second thing, set A is called domain. Set B is called codomain. And the collection of images from the domain are called as images. Collection of the collection of the images from the codomain are called range. Collection of the images from the codomain are called what? Range. Clear? So from this particular small example they have explained. Now let us take another example. Okay, I will take set A as set A contains some elements, that is X, Y, Z. Set B contains 1, 2, 3. Okay. Now, I will have some relation. This is X, Y, Z. 1, 2, 3. Now I will do mapping. X maps to 1, Y maps to 1, Z maps to 1. See, all are mapping to a single element. This we don't make, this will not make us problem. From domain, this is unique. From domain, this is unique. From domain, this is unique. All the elements may have the same image. That's not the problem. But the single element must not have two different images. The single element cannot have two different images. All the elements can have the same image, but the single element cannot have two different images. From here, it must be unique. See, this is unique. This is not unique. Clear? So, if this condition satisfies, this is going to be function. Now, this is called mapping. Now, I will take domain is set A. In set A, what are present? That is X, Y, Z. This is domain. In set B, 1, 2, 3. This is codomain. Clear? Now, range. equal to singleton set 1. Range is equal to singleton set 1 because this one is only image for all these three elements. This one is the only image for x, y, z. So that's why the range contains only one element, that is 1. This f becomes mapping straightforward. A is called domain, B is called codomain, and the range is singleton set 1 because that is only the image of all the elements in domain. All the elements in domain. Clear, students? So see this diagram very carefully. This is set A. It is called domain. This is set B. It is called codomain. In that codomain, some of the part of codomain will become range, because here this one is range. It is present in codomain. It is present in codomain. This one is present in codomain. That's why the range is subset of codomain. Please remember, range will be subset of codomain. Range will be a subset of codomain. This is always true. This is always true. The elements of range may be equal to the codomain, or it will be the lesser than codomain. Please remember all these important points, very very important. The elements in the range can be equal to codomain, or they can be lesser than elements in the codomain, because range is always subset of codomain. Range is always a subset of codomain. Are you getting my point? So please remember, when R satisfies the condition of function, when R satisfies the condition of function, directly arrow diagram converts to mapping. Set A will become domain, set B will become codomain, and the collection of images will become range. And the collection of images will become range. So I think you got a clear idea of domain, codomain, and range. Very, very important. Domain, codomain, and range. Clear, students? If f is in a function from a to b, if f is in a function from a to b, a is called domain, b is called codomain. A is called domain, b is called codomain, and range is collection of images. Range is collection of images. It will be the subset of codomain. It will be the subset of codomain. Please understand this all very very important notes, or you can make these notes also. Clear? If f is in a function from a to b, a is domain, b is codomain, collection of the images called collection of images is called range. Already they have given one example. I have taken one extra example and I have solved. Clear? So you can take the notes while I am explaining to you. Otherwise I will send the PDF copy of this particular thing, so it will be very clear to you all. Okay, so this all rough work is explanation. This all rough work is explanation. This will be not in your PDF. In your PDF just the slides will be present, so that you have to read. Okay, this all is your explanation. Okay students, this explanation you must note down while I am explaining. Otherwise no problem, I will send the PDF of what is present in the slides, that you can take. No problem. Okay, so now I will go to the next thing. Okay, in this slide they are explaining how to find domain and domain of function. How to find domain of function they are explaining. That means rules of finding the domain of function they are explaining. Okay, students. So before starting the rule of finding the domain of function, first thing you have to remember the function must be defined. The function must be defined. Please remember this statement. The function must be defined. The types of function we are going to discuss in this slide. But first thing, whenever you are finding domain, whenever you are finding domain, you have to make sure that the function must be defined. That means if you give input, you must get output. Like this, suppose this is input, this is your function, and this is your output. Clear? If you give input here, if you get output here, if this is f of x. Clear? If you give input here, you will get output. By giving input, if you are getting output, then the function is defined. This is simple logical thinking, but it depends on the nature of function. Please remember, it depends on the nature of f of x, that is function. So it depends on the nature of function means what? That we are going to discuss here. See, we are going to discuss one by one. First thing is algebraic function. The first function is algebraic function. In the algebraic function, what they are saying, denominator should be non-zero. See, very, very important. Denominator should be non-zero. What is the meaning of denominator should be non-zero? This is very, very important. That's why I have said you, the first thing you have to make in your mind, the function must be defined. The function must be defined. Clear? So I will take one example, that is 1 by x. I will take 1 by x. See this example, you will understand it. If I take 1 by x and if I make x equal to 0, if I take 1 by x, if I take x equal to 0, what happens? It will become 1 by 0. We know that 1 by 0 is not defined. 1 by 0 is not defined, or this is equal to infinity. 1 by 0 is always said as it is not defined, or it is taken as infinity. Infinity also, mathematical meaning of infinity is also again, it is not defined. For example, counting of stars. Counting of stars. What you say for counting of stars? They are infinity. Infinity means you can't count them. What is the meaning of you can't count them? That is not defined. That means counting is not possible. Counting is not defined. Clear? That's why we say the counting of stars is infinity. That's not defined. And in mathematical form, whenever you get 0 in the denominator, we all know that whenever we get 0 in the denominator in the place of x, if x becomes 0, it will become 1 by 0, and mathematical definition of 1 by 0 is not defined or infinity. So we can't analyze this function. We can't analyze this function. Clear? If we can't analyze this function, then this particular term is said as what? The domain is not defined. So that's why what they are telling, the denominator must be non-zero. That means I can't give 0 to x. That means x will be not equal to 0. That means x will be not equal to 0. See, this is one of the example explanation for your understanding. Okay, because everything will be written here, but you have to understand this. That is very, very important to make understand you, or otherwise I can go on reading this. That's not that much of tough for me, but you have to understand what is meaning of that particular line. That is very, very important. The denominator must be non-zero. Why it should be non-zero? What happens if it is equal to 0? That all things I am discussed here, or I have discussed here. So if you understand this explanation, then you will know what is the first point, that is denominator should be non-zero. Denominator should be non-zero. If the denominator becomes 0, you will get 1 by 0. 1 by 0 is not defined, it is infinity, hence we can't find the domain at that particular point. Please remember, we can't find the domain at that particular point. For example, if I want to write the domain of 1 by x, I should write r minus singleton set 0. R minus singleton set 0 means this is real number set where 0 is not present. That means non-zero real numbers. Non-zero real numbers. For that it is defined. Therefore, this will be the domain for 1 by x. This will be the domain for 1 by x. Okay, very good. So let us go for the second point. Expression under the even root should be non-negative. Expression under the even root should be non-negative means, see students, I will write one example so that the second thing will be also very much clear. If I write square root of x minus 1, square root of x minus 1, and if I give x equal to 0.1, what you are going to get for this? You will get 0.1 minus 1, it will be minus 0.9. Are you getting my point? You are going to get minus 0.9. So what happens here? If negative sign is present with the root, this will become complex number. This will become complex number. Hence, it is not defined, because we are discussing only real numbers. We are discussing only on real numbers. That means this x should be in such case that this particular term must not contain negative sign with root. Negative sign with root, that means x must be always greater than or equal to 1. X must be always greater than or equal to 1. If you give a greater number for x greater than 1, if you give greater than 1, greater number minus 1 greater than 1, because here you are going to give x as greater than 1. We all know whenever you are going to take the sign plus or minus, you will take the sign of higher number, because this is subtraction. So whenever you are doing the subtraction, you are going to take the higher number sign. For example, if I take 2, so square root of 2 minus 1 will be what? 1. If I take 1.1 minus 1 will be what? 0.1. So it is also positive, no problem. So that's why from this we understand that x is always greater than or equal to 1. So this will be the domain for square root of x minus 1. X is greater than or equal to 1 will be the domain for square root of x minus 1. See, this is all rough work I am explaining. This is not your notes. This is just to understand. If you want to make notes, you have to make notes by my explanation. Your notes is already ready here on the left side. This is your notes which you have in your book, but this is your explanation. This is your rough work. That's why I am writing it as a rough work form. Are you getting my point? This is your rough work. This is not your notes. If you want to take the notes of your rough work, you have to make a points one by one whenever I am explaining. Please don't get confused. Are you getting my point? So that's why what we say, whenever x is greater than or equal to 1, whenever x is greater than or equal to 1, this particular term will be always positive and this will become in real number. If after becoming real number, we can write the domain of this. Okay. So after writing domain of this, you can take the value of x. That's what they are explaining in the second point. Clear, students? Okay, students. So now let us continue with the next functions, that is trigonometric function. Clear? So we already discussed algebraic functions. Now we shall continue with trigonometric functions. Okay. So here the first one is sin x and cos x are defined for all real value of x. That means sin x and cos x, sin x and cos x are defined for set of real numbers, set of real numbers. So I will explain this particular thing with a trigonometric function graph, trigonometric graphs. So before going to graphs, you must know some basics of graphs. That is, y-axis is called codomain, x-axis is called domain. So this is domain, this is codomain. Okay, and this will be the origin. Okay. So let us discuss this sin x and cos x with their graphs. Sin x graph and cos x graph. Clear? We shall discuss this thing with sin x graph and cos x graph. Okay. So for that I will move for the next slide, that is sin x graph and cos x graph. So see here, my dear students, this is sin x function, that is y equal to sin x. Okay. Sin 0 will be 0. Sin pi by 4 will be 1 by root 2. Sin pi by 2 will be 1. So this is the height of sin pi by 2. Next, sin 3 pi by 2 is sin 3 pi by 4 is minus 1 by root 2. Sin pi will be 0. Sin 3 pi by 2 will be minus 1 and sin 360 will be 0. So this curve gives us the outputs of sine function. This curve gives us output of sin x function. That means here domain is x-axis. Domain is x-axis. Y-axis is codomain. Domain is x-axis and y-axis is codomain. Clear? So from the domain you are going to give the inputs for x, and for y you are going to take the outputs. They will be on y-axis. Okay. So this is the graph of sin x. So see here, we already discussed vertical line test. That means if we draw a parallel line to y-axis, if we draw a parallel line to y-axis, it should cut the graph exactly at one point. See this. So this is the point where sin x graph is intersected with the vertical line drawn parallel to y-axis. Vertical line drawn parallel to y-axis. At this point, it is intersected. That means if this at this point it is intersected, means it is intersecting at only one point. You can draw at anywhere. See, if I draw here a parallel line, again it intersect at only one point. If I draw a parallel line here, again it intersect at only one point. That means this particular graph is called function. We can just prove it by vertical line proof or vertical line test. How to draw vertical line? You draw vertical line to y-axis, that means parallel to y-axis. If it cuts exactly at one point, this particular graph is going to be function. Okay, so you can see here they have given the example from minus 2 pi to plus 2 pi. That means minus 360 degree to plus 360 degree. This is plus 360 degree. Clear? That means they have given 4 quadrant example. 4 quadrant example, that is first quadrant, second quadrant, third quadrant and fourth quadrant. Clear? You can see that in first quadrant sign is positive. See this, this is the first quadrant. It is positive. Next, here second quadrant is also positive, 0 to pi. This is first quadrant as well as second quadrant. Clear? This particular diagram is first quadrant as well as second quadrant. See this, this is third quadrant and fourth quadrant. In third quadrant and fourth quadrant sign is negative, so that's why your graph is on negative side of y-axis, on the negative side of y-axis. Clear? So this is the negative inputs, this is the negative inputs, that's why they are on the negative side of, because negative input of sin x will be the negative output, so that's why they are on the negative side. Here the negative sign will come outside, and as you know, it is in third quadrant and fourth quadrant, the output is negative. Negative into negative will be positive, so it is on upper side. Clear? Whenever the graph is on positive y-axis, the output will be positive. Whenever the graph will be on the negative y-axis, it will be negative. Okay, so then here it is positive, here it is negative, here it is positive, sorry, here it is negative, here it is positive. Clear? So alternatively, positive and negative signs are going to be changed from 2 quadrants. That means it is periodic with 2 periods of time. Clear? Okay, here the periodic length is 0 to pi. That's all. That all will be in your next classes, so we shall don't discuss those things. But here you have to understand that this is the graph of sin x. X-axis is domain, y-axis is codomain. So on the x-axis, if I go on continuing from negative infinity to positive infinity, it goes to positive infinity. Here this side it goes to negative infinity. For all inputs there will be a outputs, required outputs. That means sin x is defined for x belongs to real numbers. Sin x is defined for x belongs to real numbers. Clear? So it's a very much clear idea with the graph. Okay, on the same way, see here, this is cos x. Again, from all negative to positive infinity, this is positive infinity. Here this side it goes towards negative infinity. It is defined for all the real numbers which are present on x-axis, which are present on x-axis. So that's why the domain of cos x is also again x belongs to real numbers. See, again the curve is moving from positive to negative, positive to negative, again positive, negative, positive. It goes on like this. Okay, so from this diagram you can see that x-axis, on all the values of x-axis the graph is defined. That's why x belongs to real numbers, so domain will be the real numbers for your cos x as well as sin x. Clear, students? Okay, so this we have discussed now, that is for both sin x and cos x it is defined for all real values, for all real values. Clear? Now we shall go for the second one, that is tan x and sec x. Tan x and sec x are defined for all real values of x except x equal to 2n plus 1 pi by 2. That means odd multiples of pi by 2. In the term of odd multiples of pi by 2, tan x and sec x is not defined. So why in the odd multiples of pi by 2 tan x and sec x are not defined? Because one example you can see, tan pi by 2 is infinity, or it is not defined. Tan pi by 2 is not defined, or we write it by infinity. So if I multiply this by 3, odd multiple 3 pi by 2, so tan 3 pi by 2 is also not defined. Tan 5 pi by 2 is also not defined. Clear? So it will be very much clear if you see the graph. So again we shall discuss tan x and sec x with the graphs, so that it will be very much clear to you. That means you can understand the concept for all real values of x except, see this, except odd multiples of pi by 2, because one example as I said, tan pi by 2 is infinity, that is not defined. In that particular point the graph will be not present, graph will disappear, graph will disappear. So where the graph is going to disappear, there the function is not going to define, and that particular terms are not included in your domain. See, in domain, those disappearing points are not included. For example, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2. These particular terms are not included, because at this particular terms tan becomes infinity. If tan becomes infinity, graph will disappear. If graph disappears, it should be considered as function is not defined. So that particular points has to be removed from your domain. That particular points has to be removed from your domain. That's why they are removing 2n plus 1 into pi by 2. That's why they are removing this x value, that is x equal to 2n plus 1 pi by 2. If they remove this, then the domain will be well defined. So now let us see the graph of that. Okay. See here. This is the tan x graph. See this. This is pi by 2. At pi by 2 what happens? It goes towards infinity. Here it again goes towards negative infinity. This is minus pi by 2. So in between minus pi by 2 to plus pi by 2, the graph is present. See this, the graph is present. But when it comes to pi by 2, the graph disappears here. The graph disappears here. Clear? Again, when it comes to for minus pi by 2, the graph disappears here. That means it's having the breaks. The breakpoint are present. The breakpoint are present at pi by 2, here at minus pi by 2. See this. The next one is at 3 pi by 2. This is at 3 pi by 2. Again you have a break. See this. Here you are having a break. Here this is minus 3 pi by 2. Clear? Again here you are having a break. So the breaks are present at odd multiples. Odd multiples of pi by 2. So that's why the tan is not defined at 2n plus 1 into pi by 2. Therefore, the domain, in the domain these points are not considered. In the domain these points are not considered. Therefore, domain is written as real number minus 2n plus 1 pi by 2, the real number set minus 2n plus 1 pi by 2. Clear? On the same way we can see at the sec x also. See here, this is minus pi by 2, this is plus pi by 2. See, the breaks are present in the graph, the breaks are present. That's why at that particular point the graphs are not present, the graph will disappear, the graph will have break point. If the graph is having a break point, at that particular point the function is not defined, therefore that particular point, so see here also it is having breaks, here also it is having break point. Okay, so this is pi by 2, this is plus 3 pi by 2, and this is minus 3 pi by 2. So at odd multiples of uh, pi by 2, the tan x and the sec x are having breakpoints that we can see in the graph. From this particular thing you can consider that the domain, see, the domain of tan x and sec x are defined for all real numbers minus 2n plus 1 pi by 2, odd multiples of pi by 2. You have to remove odd multiples of pi by 2, that's all. Clear? So except odd multiples of pi by 2, in remaining the for the remaining real values, this particular function is defined, that is tan x and sec x are defined. So the domain of tan x and sec x is real numbers except odd multiples of pi by 2. Clear? Okay. Next, I will leave this as homework. I will leave this as homework. So you refer NCERT textbook. In that NCERT textbook, the graphs of cot x and cosec x are given. So where the breakpoints are present, there the graph will disappear, and that particular points has to be removed. Okay, so cot x and sec x real values, all real values of x, all real values of x except x equal to n pi. So you refer that graph, so that multiples of pi, 1 pi, 2 pi, 3 pi, 4 pi, minus 2 pi, minus 3 pi, so on. At that particular point, the graph is going to disappear. Therefore, it is going to have an breaks, and at that point, the graph is not going to be present. So, for that reason, cot x and cosec x are not going to be defined for that values. Okay. If it is not defined for that values, we should not consider that particular points. Okay, if it is defined, no problem. If it is not defined, that points has to be removed. So therefore from real numbers they are removing the multiples of pi, the multiples of pi. Clear? So this is how we are going to find the domain. Now you have understood that domain, you have to please remember it. Domain of sine is what? That is real number set. Domain of cos x is what? That is also real number set. Domain of tan x is what? R minus 2n plus 1 pi by 2. This is also for sec x. On the same way, for cos x and sec x, cosec x, r minus n pi is your domain. That means all real numbers except n pi. All real numbers except n pi. Clear? Okay.